So this video is for the second graspable math activity. When you have a quadratic with an a value of 1, under the formulas we have a manually factoring. One of the comments I talked about in terms of simplifying a fraction, that if you have a factor, or in this case factor that of x plus 3, that most likely there's an x plus 3 factor in here. So two factors would be x plus 3 and x plus 9. And then because we have an x plus 3 divided by itself, that's going to be a value of 1 as long as x is not equal to negative 3. So the final answer is x plus 9. In the second problem, both the terms here have an factor of x in it. When factoring out variables, including numbers, I always recommend starting with the lowest base with an exponent. So I would put the x on top of x squared, for example, instead of x squared on top of the x. I just find that it's depending on the situation, going from the smallest to the largest tends to create fewer issues. Same thing with simplifying fractions. If I put the x squared on top of the x, I get negative 1, which is true, because if I subtract 1 minus 2, I get negative 1 exponent. But try and turn this back into a positive exponent, the program will not let me do that. So one of the comments I've made is that when you're simplifying fractions, always again put the base that has the lowest exponent on top of the larger one, and then it will simplify things and make the exponent positive when it subtracts those two exponents. All right, so in problem number 3, we're going to be doing the factoring twice. So using the formula, we're going to break this down into two factors, so x minus 6 and x minus 5. It's just clicking on the addition problems, determine distraction. And if the second one, again, most likely one of these two are a factor of this, and it is the x minus 6. So it'll be x minus 6 and the other factors x plus 4. So this will have a value of 1 as long as x is not 6. So the final answer is x minus 4 over x minus 5 over x plus 4. Again, I see there's a common factor of x here, so I place the smaller exponent on top of the larger. And then in terms of simplifying these, I want to keep the exponent positive, so I'm going to put the x the first on top of x cubed, which will, when I subtract those exponents, I get a positive 2. All right. So in this problem, factoring the denominator, the x plus 7, x plus 5. Now for the numerator, this actually is a pair of conjugates, or we'll call it difference of squares. But if I put the difference of squares formula on top of it, it doesn't highlight it. And the reason why is because the way the program is written, they want literally both of these to be written as squares. So if I click on keyboard and then negative 49, change that to a 7 squared. Now both of these are written as squares. Then if I click on the difference of squares, it will actually factor into the x plus 7, x minus 7 factors. Just again, just a little, this is the way they've programmed it for this particular rule. So x plus 7 divided by itself is going to be 1 as long as x is not negative 7. So in this one here, the denominator would be x minus 9, and x minus 6. The reason why I've started with these is because in the numerator I noticed that this is another difference of squares or pair conjugate, same thing here. So this one here is going to have an x minus 9, and this one here is going to have an x minus 6. But again, to be able to use the formula, we need to change this minus 6 squared and minus 9 squared. So then we can use our difference of square formula. So it will factor them for us. So x minus 9 divided by itself is 1. So again, as long as x is not 9, same thing. Oops. Same thing here. X divided by 6 by itself is going to give me, again, nature of 1 as long as x is not 6. In the numerator here, this definitely is factorable, and it looks like it would be x plus 9 and x minus 4. In the denominator, this is, I have a factor of in each term of x. Again, this is where I'm talking about going from the large to the smallest. If I go from here to here, for example, to factor it out, and then I factor on top of this, for example, it's not that we can't simplify this, and so this this set of parentheses in here is simplified by putting the x inside of it. I mean, it's possible to do this easily, and so we can end up with this is our factor of x in our quadratic. The one of the comments I made is that if you would start with the lowest exponent and move to the largest, and the lowest to the largest, the second factor here, the quadratic, actually will be in the right form. You don't have to try to simplify it. So in the denominator here, the quadratic would be x plus 9, x plus 1. So this will be the final answer. Alright, so in this one here, I can do, this is 4 over 12, which would be 1/3. And if I have x divided, x over down, put the x in the denominator, subtract the exponents, get x squared. You can factor this, and hopefully again, there's a factor of x minus 9, which there is. So x minus 9 x minus 5. So this is going to be a value of 1. So final answer is 1 over 3x squared times quantity of x minus 5. And in the last problem, the numerator is factored. There's nothing I can do to simplify the numerator. In the denominator, I have two factors are x minus 8 and x plus 4. All right. So if you have any questions on any of the problems, please let me know.